In laser welding, everything appears stable from the outside, but inside the weld spot, a highly dynamic thermal process takes place. Within just a few milliseconds, it is decided whether a component will remain structurally reliable, or whether invisible stresses and micro cracks will develop. The decisive factor is the line energy within the weld spot. It determines how temperature evolves during a single pulse. It is not power alone that matters, it is the temporal distribution of energy. The quality of a weld is determined not by power alone, but by how energy is distributed in the weld spot over time. Here, we see a single laser pulse with a duration of approximately 5 milliseconds. The molten pool reacts turbulently. It begins to boil. It loses stability. Energy is introduced without control. After the pulse, temperature drops abruptly. What becomes visible here is a thermal shock. Without control, the pulse overheats the weld spot and causes a thermal shock. These rapid temperature changes directly determine the so-called T8 to 5 time, the cooling phase between 800 and 500 degrees Celsius. Within this temperature window, the resulting microstructure is defined. If cooling is too rapid, hard and brittle martensitic structures form. If cooling is too slow, coarse-grained structures develop, reducing toughness. Both scenarios increase the risk of cracking. The problem is not the pulse itself, it is the lack of control over line energy within the weld spot. If cooling is too fast or too slow, the microstructure becomes unfavorable and cracks can occur. Superpulse technology addresses this exact physical limitation, not by increasing power, but by precisely shaping the energy within the pulse duration. The temperature inside the weld spot is actively controlled with microsecond-level temporal resolution. Superpulse technology shapes the energy within the pulse to control the temperature in the weld spot. In comparison, a completely different behavior becomes visible. The molten pool remains calm and stable. No turbulence, no boiling. Energy is not released uncontrollably, it is guided. The T8 to 5 time remains within a defined optimal range. Stresses are prevented before they can lead to cracks. With controlled energy, the molten pool remains stable and cracks are prevented. What becomes visible here changes industrial practice. High-carbon tool steels, nitrided components, coated medical parts, high-strength steels used in shipbuilding. Materials previously considered critical can now be welded reproducibly and crack-free. Not through more energy, but through controlled energy. Controlled energy makes previously difficult materials reliably weldable. Superpulse technology is a proprietary development of Sigma Laser GmbH. It overcomes the physical limitations of conventional pulsed lasers and enables controlled microstructure formation within the weld spot for the first time. Superpulse technology enables controlled welding where conventional pulsed lasers reach their limits.